Unit 5, Lesson 1. We are going to be working with negative exponents. So today we are rewriting negative exponents so that we can simplify exponential expressions. And you'll know you're able to do it when you can rewrite the expression with only positive exponents. So let's first take a look at what an exponent is. The exponent of a number says how many times to use the number in multiplication. So for example, 8 to the second power, so this is our exponent, it is attached to the number that it's next to. And it is telling us how many times to use that number in multiplication. So in this example, 8 to the second power is equal to 8 times 8, or 64. In words, when we see something like this, we would call it 8 to the second power, 8 to the power of 2, or 8 to the power 2, or simply, when we have second power, we can call it squared, third power is cubed, and then beyond that, we just call it to the fourth power, to the fifth power, to the sixth power, so on. So in general, something to a base to the number power tells you to use a in a multiplication n number of times. So again, if we had 6 to the fifth power, a common mistake that students make is they will do 6 times 5. But what this means is that there are 5 6s multiplying together. And then you would actually go through and calculate that. 6 times 6 times 6 times 6 times 6. So what about if the exponent is negative? We can think of negatives in the same way as opposites. If a negative is the opposite of a positive, and positive exponents mean repeated multiplication, what would be the opposite of multiplication? Division. Division is the opposite of multiplication. So a negative exponent means how many times to divide by the number. So 8 to the negative second power, we could also write like this. 1 over 8 times 8, or 1 over 64. Because the exponent is negative, we change our expression to a fraction, which is division. And we'll practice this with some of the examples. You'll see kind of how this applies. So when it's attached to a number, we move it into the denominator and then evaluate it. We can also apply this principle to fractions where there are negative exponents in the denominator. So if I have a negative exponent in the denominator, I can move it to the numerator to make it positive. And you'll see some more of that again in the examples. So let's take a look at some examples. X to the negative third power, this is sitting over 1. And the way that I like to think about these is I think that if it's to a negative power, it is not happy where it's at in the fraction, and it needs to move. So x to the negative third is unhappy being here. It's in the wrong place. It's unhappy because it's in the wrong place. So I need to move it to the denominator. So if I take this x to the negative third and I move it down here, it is now positive. It's now happy because it's moved to the right place. And then I'm not necessarily moving this 1 up because this is 1 over 1, but I do need to put a placeholder there if I have nothing for my numerator. Okay, so let's take a look here. A common mistake that I see students make is they would write their answer like this. And this would be incorrect. Let me show you what the correct answer looks like, and you can compare. So this is the incorrect answer. a correct answer would look like this. So the difference is that the 3 is its own term, or it's its own value, and it is not being affected by the -2. If the whole thing was in parentheses, then I would have to move the whole group. But because there aren't parentheses to group this together, the -2 is only attached to the x. So only the x needs to move. The 3 would stay where it's at. So this is 3 to the first power, and this is x to the -2nd power. Every number or every term we see, every variable we see, has its own power. So this is 2 to the first power, x to the third power, y to the -4th power. So to rewrite this, I always like to use my like a fraction bar, and then I go one piece at a time. Does my 2 need to move? No. Does my x to the third need to move? No. Does my y to the -4th need to move? Yes. When I move it, it becomes positive. So this needed to move down. Okay? So for this one, and you'll see, hopefully pretty quick, you can look at them and say, okay, the 7 stays, the x to the -5th needs to move, the y to the -8 needs to move. Done. Okay, x to the -9 again. This is sitting over 1, so it needs to move down to the denominator, and I use 1 up top for my placeholder. So this 5 stays, x to the -3rd moves down to become x to the +3rd. Means it's in the wrong place. So we just kind of identify what needs to move, and then we move it. Let's continue taking a look at some of these. And what I want to show you, and I'll show you one like 4, just because. Again, I'm looking at each piece. Does the 3 need to move? No. Does y to the first need to move? No. Does x to the -2nd need to move? Yes. Does z to the -2nd need to move? Yes. Once they move, they become positive. And it kind of works the same way. I could pull this y. If I were to pull this y down, this is now y to the -1st power. But I want all of my answers to be positive variables, so if I move it back up here, it's now y to the +1st power. So you can move things around, but if they're already in the wrong place. So now we have, and this is just kind of a little bit additional, but think about this. I have m to the -2nd needs to move down to become m to the +2nd. This 3 doesn't need to move, and this m to the 4th doesn't need to move. If I don't have anything, I'm going to put a 1 as a placeholder. But think about it like this now. I have 4 m's and 2 m's, so I actually have a total of 6 m's. Right? Because if we were to break this up, I have m times m times m times m. That's for my first term. And then for my second one, I have, these are multiplying down here, m times m. So now I have a total of 1, 2, 3, 4, 5, 6. So I actually have m to the 6th. Let's see, I don't want to get too involved here, but the idea is if I have a negative exponent, it's just in the wrong place. So if it's negative and it's in the bottom, it needs to move up. I have 3 up top, and I'm adding 2 more to it. So I have n to the 3rd, and then I move my n to the -2nd up to make it positive. And now I have n to the 5th over 4. Okay? So, I mean, we can look at really kind of ones that seem complicated. I always move them first. Anything that's, so I'm going to go a to the 2nd doesn't need to move. B to the negative 1st does need to move. 3 doesn't need to move. I like to write that off to the left. A to the negative 1st needs to move. And b to the 2nd doesn't need to move. Now that I have all positive values, I can just kind of combine them up. So I have 3 a's multiplying up top, right? Because that's a to the 2nd is a times a, and a to the 1st is a, and a times a is a to the 3rd power. And then down below I have 3, and then I have b to the 3rd power. Okay, so that's a little bit just extra there. I'll do one more. And for this one, we have actually these 4s, so we want to reduce 4 over 4 reduces to 1 over 1. X squared doesn't need to move. Y to the negative 4th does need to move. X to the negative 3rd needs to move. And y to the 2nd does not need to move. Now that I have positive exponents, I can rewrite this. X to the 2nd and x to the 3rd make x to the 5th. And y to the 2nd, y to the 4th make y to the 6th. And I've simplified now all the way down.